If you like, you can say 0 index. What is an index? An index can also mean a power. So you can also say 0 power or a 0 exponent. Meaning, what happens to a number that has a power of 0? When the exponent is 0, for example, a to the power 0, what happens to this number? How do you simplify this? How do you take this to the lowest form? Now, of course, we are going to do a little bit of proof here. What I'm going to do is, let's say 3 to the power 2 divided by 3 to the power 2. Now, I will simplify this. I want to solve this naturally, meaning I have to change 3 to the power 2 into a natural number, and that is going to be 3 times 3. When a number is raised to a power, you multiply it to the times it is being raised to the power. So the number multiplies itself. This is not 3 times 2. This is 3 times 3 because the power is 2. So 3 multiplies itself 2 times. And when that happens, you have 9, meaning 3 times 3 is 9. Divided by 3 to the power 2 is also 9. Now, how many groups of 9 are in 9? It's just one. There is just one group of 9 in 9. So when you divide 9 by 9, the answer should be 1. Now, when you solve this, naturally, what you have is 1. But remember the division law that we just did 1 minute ago. I would say 1 minute ago because it was in the previous slide. When you have 3 to the power 2 divided by 3 to the power 2, what happens? In this case, we say because the bases are the same, you take one of the base. Take one of the base. Take 1, 3, and then subtract the powers, subtract the exponents. So this is 2 minus 2. So 3 to the power 2 minus 2 gives you what? 3 to the power 0. So you can see when you solve this, the answer what you got is 1. When you apply the division law, the answer that you get is 3 to the power 0. So that means 3 to the power 0 is 1. So the conclusion you get from this generalization is, anytime a number is raised to a power 0, it does not matter how big or how small the number is. It does not even matter if it is a letter. Once it is raised to the power 0, the answer is 1. So a to the power 0 is 1. Okay, 1000 to the power 0 is 1. M to the power 0 is 1. Regardless of the value of the number, it does not matter how big or how small the number is. Minus 200 to the power 0 is 1. 1 million to the power 0 is 1. So the 0 exponent or the 0 power talks about this law, and you can use this in almost every principle. Once you are dealing with numbers and the power is 0, the simplification for that particular unit is just 1. So it does not matter how big or how small the number is. So long it is raised to the power 0, the result is 1. Next. Now, before I go into the negative exponent, the negative law of indices, I just want to remind you that rules are everywhere, you know, and if you want to succeed in life, you have to know what the rules are. So it is important also, if you want to succeed in simplifying exponents, terms in exponents, or numbers that are written in exponents form, you must be able to remember these rules. I already talked about the multiplication law, the division law, and the 0 index. The 0 index can also be referred to as the 0 power. Also, you can call it, if you like, the 0 exponent. But what is it about? It's about when a number is being raised to the power 0. It does not matter how big or how small the number is. Once it is raised to the power 0, is 1. That is important, and these laws, we need to be able to remember them if we want to succeed in simplifying numbers in indices. Now I'm going to talk about one of the most useful law, but also very controversial. I wouldn't say controversial, but I will say it is a bit like you need to know something more. Yeah. So I will try to explain the negative exponent or the negative power. If you like, you can call it the negative index. Once you see exponent, you can replace it with power or index. So if you say the negative power, it is referring to a number that is raised to a negative power. For example, if I have m to the power minus 1. A little bit about negative. Mathematically, if something is negative, it's not simplified. If you write this expression, for example, minus 5 plus a, mathematically, this is not simplified. Minus 5 plus a, to simplify that, you write a minus 5. This is because negative numbers do not begin an expression. It's always advisable that when you have an expression, a group of terms, always start with the positive number. So in this case, you can see this one is simplified, but that one is simplified. So it's important for us to recall that. Now, how do you write this number without a negative power? That is the job. That is what we need to learn right now. That's what we need to talk about. How do you write a term in a negative power without the power being negative? How do you nullify this negative sign? How do you remove this negative sign? Now, first, there are two keywords that I will talk to you about. One is reciprocal, and the other term is coefficient. These are two very useful words that you need to remember. First, the reciprocal is simply, I would say, turned upside down. If the head is up and the toes are down, if I ask you to reciprocate it, you take the toes up and bring the head down. That's reciprocation. Once something is up, you flip it upside down, is reciprocating. So if you are to reciprocate, you just look at the number and think about this number as a fraction. You know, every number can be written as a fraction. If I ask you the number 5 as a fraction, this is the same as 5 over 1, because I know there are 5 groups of 1 in 5. So 5 over 1 is the same as 5. So anytime I see 5, I can just see it also as 5 over 1. Yeah, 5 is a natural number, but as a fraction, I can see it as 5 over 1. So if I ask you to reciprocate 5, in essence, I'm just seeing it as 5 over 1. So if you reciprocate this, this will be 1 over 5. So anytime you have to do a reciprocation, you have to flip a fraction. You have to flip it. You have to, like, the denominator goes up and the numerator comes down. And that means you have to see every number as a fraction. You have to be able to see it as a fraction. So let's look at that. That was reciprocation. Now, coefficient means the number that comes before the number that comes before a variable. What is a variable? A variable is something that is not known. For example, if I write x, what is x? X is something that I don't know. It's something that I am using to represent, but we don't know what it is. So x in this case is a variable. Now, what's the coefficient? The coefficient is the number that comes before the variable. For example, if I have 2x. Now 2 is the coefficient. It's a term that comes before an unknown letter. An unknown, let me just say an unknown. A term that comes before an unknown. Yeah? So what happens now if I want to write a to the power minus 1 without a negative power? So the negative law says, first you have to reciprocate a. What is the reciprocal of a? See it as a fraction. A as a fraction is a over 1. If you reciprocate it now, it will be 1 over a. So this will be 1 over a. After reciprocating a, raise it to a positive power. Once you reciprocate it, the negative power is being nullified, and then you can raise it to a positive power. So this is 1 over a. So this is about the negative law, just writing the number without a negative power. If I give you 2 to the power minus 3, and I ask you to simplify this, first I want you to reciprocate 2. What is the reciprocal of 2? Think about it. Pause one moment and think about what's the reciprocal of 2. Remember, reciprocation means flipping upside down. So if you want to reciprocate 2, you need to see 2 as a fraction. And 2 as a fraction is 2 over 1. Now if you see it as 2 over 1, the reciprocal will be 1 over 2. After reciprocating it, the power comes there to 2, but the power now does not become negative. It becomes positive. So what you have is 1 over 2 to the power 3, and that is 1 over 8. 2 to the power 3 means 2 times 2 times 2. And 2 times 2 times 2 is 8. Yeah? So still on the negative exponent, the negative power, when a number is being raised to a negative power, for example, x is being raised to the power negative 1, first you need to know what is the reciprocal of x. To know the reciprocal of x, you have to see x as a fraction. And when you see that, then the numerator comes down and the denominator goes up. So this is 1 all over x. Once you reciprocate x, now the power of x changes from negative to positive. It becomes 1 over x to the power 1, and any number to the power 1 is that the same number. Now I will say this very important thing. When you have a variable m, for example, the coefficient of this variable is 1. The denominator of this variable is 1. The power of this variable is 1. So you have to see that this I can write m only, but I have to see that in some instances, if I want to see m as an exponential term, I know the power is 1. It's just m to the power 1. If I want to see m as a fraction, it's just m over 1. So any number over 1 is that the same number. Any number to the power of 1 is that the same number. The coefficient 1 times any number is still that the same number. So we said unit powers, unit denominators, unit exponents, they are not written. You don't need to write m to the power 1. You can just write m. M to the power 1 is m, so no need to write the power 1. So when a power is unit, when the power is 1, mathematically you don't write it. When a coefficient is 1, mathematically you don't write it. And when a denominator is 1, mathematically you don't write it. Yeah, so this is important. So I will talk to you about the next law now, which I call the power law. The power law. Now, when a number, for example, m, is raised to the power a, the same number is raised to another power b. Now, m has a power a, m has a power b. Now, this law is saying you multiply these two powers, multiply a and b. So this is m to the power a times b. When a number is being raised to a power, for example, m is raised to the power a, m is raised to the power b, the power law states multiply these two powers together. Multiply the two powers. Okay? So if you have 2 to the power 3 and 2 to the power 4, 2 has a power of 3, 2 has a power of 4. This simplification will be 2 to the power 3 times 4, and that gives you 2 to the power 12. Alright, so anytime a number is raised to a power, you multiply. Anytime a number has different powers, you multiply the powers together. So even if the number has 3 powers, you multiply all the powers together. For example, 2 raised to the power 3 to the power 2 to the power 4. This is going to be 2 to the power 3 times 2 times 4. And that gives you 2 to the power, this is 6 times 4, that is 24. It's 2 to the power 24. So when a number is raised to a power, it does not matter how many powers does it have. Always just take the product of the powers, multiply all the powers together. Now I will also expand this law a little bit, and I will call it the product power law. I'm going to explain that This time is when you have a product inside the bracket. I call it the product power law. The product power law. When you have a product inside a bracket, for example, 2ab, and this has a power 3. Now, what happens to the product? Now, this is a product, so that means it's 2 times a times b. That is what gives you 2ab. Huh? So 2 times a times b gives you 2ab, and this is raised to the power 3. You are going to distribute this power to every term in the bracket. So the power 3 distributed to 2, the power 3 distributed to a, the power 3 distributed to b. So this is going to be 2 to the power 3 times a to the power 3 times b to the power 3. So this is 2 to the power 3. Remember, it's not 2 times 3. 2 to the power 3 is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So 2 to the power 3 is 8 times a to the power 3 times b to the power 3. Because we don't know a and b, that remains a to the power 3 and b to the power 3. So this answer, in its final simplification, will be a to the power 3, b to the power 3. That will be the simplification. So the power law is there, and this one is the product power law, when you have a product inside a bracket. Now let's look at this other product. If you have 2a to the power 2, b to the power 3, again, this is raised to the power 4. Now, what happens here? Now, first, we can write this in its initial form, meaning this is a product, so it was from multiplication that you got this. So we are going to write this in terms of multiplication. So this will be 2 times a square, which is a to the power 2, times b to the power 3. Everything has a power of 4. Because of the product power law, we are going to distribute this power to 2, distribute it to a, and distribute it to b. But watch out, when you distribute 4 to a already has a power of 2, meaning a is going to have 2 powers. Another law comes in, which is the law we just learned in before. So this is 2 to the power 4 times a to the power 2, which is this one, then distribute the power 4, times b to the power 3, which is this one, then add the power 4, distribute the power 4 to it. So 2 to the power 4 is 2 times 2 times 2 times 2, and that gives you 16. Now a to the power 2, a to the power 4. One number has more than one power, you multiply the powers together. So this is going to be 16 times a to the power 2 times 4. That is 8 times b to the power 3 times 4. That is 12. Multiply the powers together. When a number is raised to a power, that the same number has another power, the power law states you multiply the 2 powers together. So simplifying this will be 16a to the power 8, b to the power 12.